this video, we will see a problem on pentagonal pyramid. Here is the question. A pentagonal pyramid, edge of base 25 mm, axis length 65 mm, has one of its edge of base in HP and triangular face contained by that edge of base is inclined at 50° to HP. Draw the projections of the pyramid if the edge of base which is in HP is parallel to both HP and VP, keeping the apex nearer to VP. So these conditions, I'll explain it in the problem itself. The first thing we have understood is that the type of solid is a pentagonal pyramid. So I'll draw the diagram and explain it. So here we have a pentagonal pyramid whose base is in the shape of a pentagon and it has 5 corners at the base. Those 5 corners are connected to a common vertex also called as apex. Here this is an apex. I'll denote it as point O. So these slant edges are connected to the apex, forming triangular faces. And now, when this pentagonal pyramid is there, in the question it is given that pentagonal pyramid edge of base 25 mm, axis length 65 mm has one of its edge of base in HP. So when the condition is given for edge of base in HP, we have to keep that base edge on the right hand side. Means pentagon can be drawn in two different ways. The base edge is 25 given. (72° angle should be marked for the base edges of the pyramid. So the edges are inclined at 72° angle for the pentagonal pyramid, or we can say for the pentagon. Next, that base edge is of 25 mm side given. So measuring 25, marking on one side, also on the other side. Then keeping the same distance, drawing an arc, cutting it. So here I am getting a point, joining it. Then keeping the midpoint of it. So half of 25, 12.5, joining it to the opposite corner. Then taking the midpoint of any one of the sides, taking half of that, so form the midpoint, joining it to the opposite corner, and where these two lines intersect, that will give us the apex, point O. And now I'll make it dark. So this is one way of drawing the pentagon, and in the other method, here it is resting on its corner. In the other method, it would be resting at its edge. Now here I'll say that the corner on which it is resting is corner A. So in the question, the condition given is the pentagonal pyramid has one of its edge of base in HP. So if it has one of the edge of base in HP, we can say that the complete base is in HP. It means the pentagonal pyramid is kept on the ground, also called as HP. So when we are looking from top, then we are going to see the pentagon, and it should be seen in such a way that it is resting on its edge of base. Now this condition which I have used, here it is resting on its corner, means we are taking the right hand side as the reference, because we would be tilting the solids onto the right hand side. So since it is resting on this corner, this condition is not correct. Instead of that, here we should get an edge. It means this pyramid would be reversed. Point A will come on the left hand side, and this edge, I'll call it as 1 2, will be on the right hand side. So initially I'll draw the pyramid, that is the pentagon, by keeping the edge onto the right hand side. That will be the initial condition. So with this, let us get started with the solution to this problem. XY line, VP, HP, pentagon will be drawn here, and in this case edge should be on the right hand side as I have explained. So now here I'll keep the edge onto the right hand side, and I have drawn this pentagon to the dimension which is base 25. So I'll be measuring the 25 distance here from 1 to 2 and marking it over this vertical line. Then drawing 72-degree angle with the help of both the points. Next, marking this base edge which is 25. The distances I have marked it onto these angles. Then drawing an arc, cutting this arc. So here we are getting this point, joining it with the help of light lines. Taking the midpoint, joining it to this corner, opposite corner. Then taking any one of the sides, taking its midpoint and joining it to the opposite corner. So here I get the intersection point, which will be called as the apex O, joining all the corners to the apex to get the slant edges. Then I'll be giving the notations to it. Projecting the pyramid in the front view. The axis height is 65 mm. So measuring 65 over this axis, joining it with the help of light line first. Giving the notations in the front view. O dash, 1 dash, 2 dash, 5 dash, and here we have 3 dash, comma 4 dash. And then making it dark so that the initial condition is completed. Here is the axis of the pentagonal pyramid. Now, this is the complete front view and top view of the pentagonal pyramid. The next condition is its edge of base in the HP, so that edge of base is 3 to 4, and triangular face contained by that edge of base is inclined at 50 degree to HP. Inclination given with HP, that is denoted as theta. So theta is 50 degree, and this inclination will be seen in VP. So the triangular face contained by H34, that is O34, and when we are projecting it in the front view, that triangular face looks like a slant edge, which is O dash 3 dash 4 dash. So in the next condition, this edge is inclined at 50 degree to HP seen in VP. So I will make this edge inclined at 50 degree. Taking a point here. Measuring an angle of 50. Drawing a light line. Next, measuring this slant edge, which is nothing but a triangular face looking like a slant edge in the front view, 3 dash 4 dash up to O dash, marking it over this line. Then keeping the same distance, I'll draw a light arc from here. Now here we have apex O dash, this is point 3 dash comma 4 dash. Then keeping the distance of the base 3 dash 4 dash up to 1 dash, keeping here and cutting this arc to get this point, joining it will give us that inclined pyramid. And now here if we see, the edge, that is nothing but this triangular face, is inclined at an angle of 50 degree to HP seen in VP. Then I'll mark the distance of the axis from point 3 dash 4 dash up to this axis. I'll be keeping the distance here and marking over this, giving the notations. Here we have 1 dash. So now here I'll join this point, and this is indicating the distance of apex. So connecting it with O dash will give me the apex. Then from 3 dash 4 dash, I'll be taking the distance up to 2 dash 5 dash, marking it on this base, joining it will give me the slant edge, and this is point 2 dash comma 5 dash. Now I'll make it dark. So this is the front view of that inclined pyramid in which the triangular face O dash 3 dash 4 dash is inclined at 50 degree to HP. Now I'll draw the top view for it, and in the top view, observer is here, and when the observer is at this location, those points needs to be projected first which are closer to the observer, like point O dash, which is the apex, is closer, and here point O from the top view. Connecting it will give me point O. then 1 dash, so 1 dash and 1, wherever they intersect, that will give me point 1, then 2 dash, 5 dash, point 2 is here, so this is point 2, then point 3 dash, 4 dash, and point 3, four dash and 3 dash are onto the same line, so projecting point 4 over this same line will give me point 4, then point 5 and 2 are onto the same line, that gives me point 5. Now joining it, taking care of visibility. From the top, if the viewer is saying O dash to 1 dash will be visible, so it will be made dark. Then 1 to 5, that is also visible because 1 dash, 2 dash and 1 dash, 5 dash are closer to the observer. So 1 to 5 visible, 1 to 2 visible. Next 5 will be connected to O because this edge O dash, 5 dash is visible. Then the edge O dash, 2 dash is also visible. Then this edge 3 dash, 4 dash, which looks like a point in the front view. In the top view, when the observer is here, this edge is not visible, so it will be hidden going behind the observer. That is why edge 3 to 4 is hidden. So again connecting it with 4 to 5, that will also be hidden. And 3 to 2 hidden. Next 4 to O will be connected with the help of dotted line again, that is also hidden. And O to 3, so it is hidden. Means this is the top view of this inclined pyramid, and here if we see the edge 3 to 4, this edge is parallel to HP and perpendicular to VP. In the question it is given that draw the projections of the pyramid if the edge of base, which is in HP, that is 3 4, is parallel to both HP and VP. So here in the first case it is parallel to HP. Now I will make it parallel to VP, and the condition is keeping the apex nearer to VP. It means it will be tilted in such a way that apex is there at the top. So for that, I'll draw a light horizontal line and projecting it slightly upwards as well. Drawing a light horizontal line. Then measuring this distance 3 to 4, because this is the edge to be made parallel to VP, and here I am making it parallel to VP with the apex nearer to VP as it is said in the question. So this is giving me edge 3, here it is 3 and 4. Then I want these points, and for that first of all I'll mark the center of this, that is from point 3. I'll take the distance up to the center so that I get this line which is connecting O to 1. So getting the midpoint of this, and next drawing a perpendicular through it. Drawing a perpendicular line. Over this I'll mark from this edge 3 4 up to distance 1, up to 1. So here I will be getting point 1. Then for points 2 and 5 I'll require this yellow line which is vertical. Now it will become horizontal. So from 3 to 4 up to this yellow line or light line, marking it and then drawing parallel line through it, measuring the distance from the center up to point 5, and same will be the distance up to point 2. So measuring it and getting the points, point second and point fifth. At last we have to mark the apex. For that I'll take the distance from point 1 up to the apex, and from point 1 keeping it over here I'll mark it up to the apex. So this gives me point O. So now here I'll be joining these points in order like I have joined here. So connecting O5 and O2 first, then 5 to 1 and 1 to 2. Next O to 1 is connected, then 3 to 4 is hidden, drawn with the help of dotted line. 2 to 3 is also hidden. 4 to 5 hidden. O to 3 will be connected. O to 4 will be connected. So this is the top view of the pyramid when it is tilted in such a way that this edge 3 to 4 is parallel to VP and apex is nearer to VP. It means it is far away from the observer. So observer is there at the bottom. So when observer is here, we have to draw the front view looking into this directions, and those points which are closer to the observer will be projected first, starting with point 1. Point 1 I have already drawn a line. So 1 dash and 1 wherever they intersect, that gives me the point 1 double dash. Next point second, and here point 2. Two double dash, then point 3 and 4. Point 3 is on XY line. So here I get 3 double dash, then point 4. Again it is also on XY line. Point 4 double dash. Next point 5. So here point 5 from top view and 5 dash from front view where they intersect, that gives me the point 5 double dash. Then at last apex is left, so apex is there on this same line. I need to get it from the front view. So here I am getting the apex, O double dash. Now joining them in proper sequence will give me the pentagon in the front view. This base is closer to observer, so all the points of the base will be visible to the observer. So connecting 1 double dash to 2 double dash, 2 double dash to 3 double dash, 3 to 4, 4 to 5, 5 double dash to 1 double dash, and then when the observer is here, O25 and O22 are visible, so they will be connected. At the same time they are outlines, so they will never be hidden, they should be dark lines. Next, O22 will be connected. So now here I'll be joining the outline edges, that is connecting O double dash to 2 double dash with the help of light line first, and then I'll make it dark. Next, here if we see, there is an edge which is 4 to 3 and the pyramid is tilted in front of the observer. So in that case, first I'll draw the visible portion. The complete base edge is visible. O double dash to 1 double dash will be connected because it is in front of the observer. Next, O double dash to 5 double dash will also be connected because closer to observer. But the edge 4, 3 and this triangular face is going behind the observer, so that will be hidden, joining it with the help of a dotted line. Next, after completing this, I'll give the dimensioning to it. The base edge is of 25 mm. Axis height is 65 mm given. So after we have given the dimensioning, we can say that the problem has been completed.